In this video, we're going to continue with section 5.1, specifically with the idea of what happens when we multiply monomials. The first example we're going to look at is example number 1, where we're asked to multiply x to the third power times x to the fourth power. And so if we were to expand x to the third power, we would really be taking x times x times x. With x to the fourth power, we're really taking x times x times x times x, and so we would have 4 x's being multiplied together, and then in the end multiplying the 3 x's from x cubed, the 4 x's from x to the fourth, and if we multiply all those x's together, we end up with an expression of x to the 7th power. Now, if you recall from prior knowledge or previous classes, if we start with x to the third and x to the fourth, that becomes x to the 7th power by taking the 3 and the 4 and adding the exponents together. If we take a look at our second example, we have 5a squared b to the fourth times the quantity 2a b to the fifth. If we take a look at the a in the second expression, that's really a to the first power, so we can add in that exponent. And so as we multiply those expressions together, taking a look at our coefficients, we're going to take 5 times 2, and that's going to give us 10. When we multiply a squared and a to the first together, that's really 2 a's and a third a, so a squared times a to the first becomes a to the third power. And if we multiply b to the fourth and b to the fifth together, that's really taking 4 b's and an additional 5 b's, multiplying all of those together, and we end up with b to the 9th. So in the end, multiplying those two monomials together, we end up with the term 10 a to the third power and b to the 9th power. So to recap, in general, the rules for multiplying exponential expressions: if m and n are positive integers, and in our general rule, m and n are the exponents. So again, if m and n are positive integers, then x to the m power times x to the n power equals x to the m plus n power. Continuing with multiplying monomials, there's also scenarios where we have a power to a power, where we have an exponent or a monomial raised to another exponent. And so with x to the fourth to the fifth power, again, exponents mean or represent repeated multiplication. And so really what we have here is x to the fourth times 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 x to the fourth. So we have 5 terms, all x to the fourth. Well, in the previous examples, we've seen that, well, when I'm multiplying with the same base, I can add the exponents, and so 4 plus 4 plus 4 plus 4 plus 4, it turns out to be x to the 20th. Now, if you recall from prior knowledge or previous classes, if we look at our exponents where we have x to the fourth raised to the fifth power, we can multiply our exponents, so x to the 4 times 5, and that will also lead to x to the 20th. If we look at our example number 8, here we still have a power to a power. It's just that we have a variable exponent, and so if we do 2 times n, that's 2n, and so our base would be x, our exponent would be 2n, so we have x to the 2nth power. In number 9, we're going to, again, we have an exponent outside of the parentheses, and so we're going to apply that exponent to each term, or I should say each base, not each term, but each base in our monomial. And so we have 2, and this, since that's the first power, 3 times 1 is 3, so we have 2 to the third power, a to the third power, so if we multiply 3 times 3, that's a to the 9th, and b to the 4th, if we take 4 times 3, that's b to the 12th. And so if we finish simplifying, 2 to the third power is 8, so we have 8, a to the 9th, b to the 12th. In our final example, with number 10, there we have 2 separate expressions separated by a plus sign. And so if we look at the expressions, or the expression on the left, we have 6a times 2a quantity squared. So if we apply the exponent of 2 to each base within the parentheses, we have 2 raised to the second power, so 2 squared, and then a to the first power becomes 1 times 2, or a to the second. And so if we simplify, we have 6a, 2 squared is 4, and then a squared, so we have 6a times the quantity 4a squared, and so 6 times 4 is 24, a times a squared is a cubed. Taking a look at the expression on the right side of our plus sign, we don't have any outer exponents to apply, so if I just multiply 3a times 2a squared, 3 times 2 is 6, a times a is a to the third, because again a to the first times a squared, we can add those exponents. And so really what we have, and I'm just going to bring down the plus signs, and I'm also going to bring down the 6a to the third. And so what we end up having is we have 24a to the third and 6a to the third. The fact that these are indeed like terms, we would have a sum now, because we're adding. 24 plus 6 is 30, and when we add like terms, the exponent stays the same. So we have a final term or expression of 30a to the third. So, in general, to summarize, simplifying a power of an exponential expression, if m and n are positive integers, so again m and n, the exponents are positive integers, then we can do x to the mth to the n power, means we can multiply the exponents. And when we have a product raised to a power, if m, n, and p are positive integers, if I have multiple bases raised to the same exponent, we can distribute that in to each base, x to the m times p power, and y to the n times p power.